that you're going to take as soon as you're done reviewing this, and you're going to find the greatest common factor for each pair of numbers. You need to use both methods to solve. The one method is to list the factors. The other one is to use prime factorization. The first set of numbers, 14 and 42. So now the first thing you're going to do is you're going to list the factors of 14. 1 times 14 and 2 times 7. Now you're going to list the factors of 42. 1 times 42, 2 times 21, 3 times 14, and 7 times 6. And the greatest common factor that they have is a 14. The second way of doing it is by using prime factorization. So let's take a look at the number 14 and break that down to 2 times 7. Then number 42, we'll break that down into prime factors. 3 times 14, and 14 can be broken down into 2 times 7. And I'm going to bring down the 3 here so I don't forget to use it. And what do they have in common? They each have a 2 and a 7 in common. So then what I'm going to do is multiply the 2 times the 7, and that equals 14. So the GCF, or the greatest common factor, equals 14. The next problem on your sheet has the pair of numbers 32 and 40. The first way to solve this would be by listing the factors. So we'll list the factors of 32. 1 times 32, 2 times 16, and 4 times 8. Now we're going to list the factors of 40. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. And the common factor that they have, the greatest common factor, is 8. Now let's try it by using prime factorization. Take the number 32. I'm going to break that down into prime numbers. We'll start with 4 times 8. 4 can be broken down into 2 times 2. And the 8 can be broken down into 2 times 4. And the 4 to 2 times 2. So we have 1, 2, 3, 4, 5 2s. So that's 2 to the 5th power. 5 2s there. So let's take a look at the number 40. We'll factor that down into prime numbers. So we'll start with 8 times 5. 8 can be broken down into 2 times 4, and the 4, 2 times 2. I'll bring down the 2 so I don't forget about it, and I'll bring down the 5 so I don't forget about that. And so what do they have in common? Well, this has 3 2s, 2 to the 3rd power. And so then they have 3 2s in common. We'll use these 3 2s, and we'll use 3 of these 2s, because there's 5 there. So that would be 2 times 2 times 2. 2 times 2 is 4, times 2 equals 8. So the greatest common factor using this method is still 8. Number 3 on your paper, you have problem pair of numbers 16 and 44. The first way that we are going to find the greatest common factor is by listing the factors of 16. That would be 1 times 16, 2 times 8, and 4 times 4. I only need to put the 4 there once. And the factors of 44 would be 1 times 44, 2 times 22, and 4 times 11. And the greatest common factor that they have in common happens to be 4. So the GCF equals 4. Now we're going to break down this problem using prime factorization. So we'll start with the number 16, and we'll break that down. We'll just do 4 times 4. I can break that 4 down into 2 times 2, and this 4 into 2 times 2. So we actually have 2 times 2 times 2 times 2, or 2 to the 4th power. And then 44, we will break down And that breaks down into 4 times 11. 11 is prime. 4, 2 times 2. I'll bring down this 11 so I don't forget about it. And what do they have in common? Well, this one has 2 to the second power times 11. They each have 2 2's. We do it this way, 2 2's, or 2 2's here, 2 out of there. So 2 times 2 equals 4. So the greatest common factor equals 4. And the last problem on your sheet is 33 and 55. So let's find the greatest common factor for those. First, we'll list them, just the factors. 33. So we have 1 times 33, and we have 3 times 11. For 55, we have 1 times 55 and 5 times 11. And the greatest common factor is 11. Now we'll do this using prime factorization. Start with the number 33. 3 times 11. So you can do with that. And 55, 5 times 11. What do they have in common? It's an 11. So the greatest common factor equals 11. If you got all these problems correct, then you are certainly ready for your quiz.